Out in the vast expanse of space where the darkness is punctuated by the light of countless stars, lies the birthplace of new celestial bodies. Stars are born in spectacular fashion, emerging from the chaotic beauty of their surroundings. These stellar nurseries, known as nebulae, are colossal clouds of gas and dust, stretching across light-years of space. Gravity is the driving force in these cosmic clouds, pulling the gas and dust particles together with an invisible hand. It pulls the gas and dust particles together, causing them to collide and merge. As the material clumps together, the core of the cloud heats up, glowing brighter with each passing moment. This central region becomes denser and hotter over time, a process that can take millions of years. Eventually, the temperature and pressure reach a critical point, setting the stage for a dramatic transformation. This is when nuclear fusion begins, a process that powers the stars. Hydrogen atoms fuse to form helium, releasing tremendous energy in the form of light and heat. This is how a star ignites, marking the birth of a new star in the universe. The Orion Nebula is a good example of a stellar nursery, a place where stars are actively forming. It is a place where stars are actively forming, a testament to the ongoing cycle of creation in the cosmos. These nebulae are not only beautiful but also crucial for the evolution of galaxies, serving as the cradles of new stars. They are the birthplace of stars, which are the building blocks of galaxies, shaping the structure and future of the universe. Once a star ignites, it enters a long, stable period called the main sequence. This is the longest stage in a star's life. During this phase, the star fuses hydrogen into helium in its core. This process releases energy in the form of light and heat, which is what makes the star shine. The Sun, our own star, is currently in its main sequence. It has been shining for about 4.6 billion years. The Sun's energy is essential for life on Earth. It provides the light and warmth that we need to survive. The main sequence is not a static place. Stars slowly evolve over billions of years on the main sequence. The length of time a star spends on the main sequence depends on its mass. Stars come in a variety of sizes and temperatures. Red dwarfs are the smallest and coolest stars. They are much smaller and cooler than our Sun. Red dwarfs are also incredibly long-lived. They can burn for trillions of years. On the other end of the spectrum are massive stars, which are much larger and hotter than our Sun. These stellar giants live fast and die young. They burn through their fuel much more quickly than red dwarfs. Some massive stars are even thousands of times larger than our Sun. The different types of stars play unique roles in the universe. Red dwarfs, due to their longevity, provide a stable source of energy for potential planets around them. Massive stars, with their intense radiation, influence the evolution of galaxies. As a star like our Sun ages, it eventually runs out of hydrogen fuel in its core. This marks the end of the main sequence phase. The core contracts and heats up. The outer layers of the star expand and cool, causing the star to swell into a red giant. During the red giant phase, the star fuses helium into heavier elements like carbon and oxygen. This process releases even more energy, causing the star to become more luminous. Red giants are huge and can engulf nearby planets. Our Sun will eventually become a red giant in about 5 billion years. When it does, it will expand to engulf the orbits of Mercury and Venus. Earth will likely become uninhabitable as the Sun's heat intensifies. Section 5, Stellar Remnants, White Dwarfs and Black Holes. In this section, we will explore the fascinating end stages of stars, focusing on the remnants they leave behind after exhausting their nuclear fuel. After the red giant phase, a star's fate depends on its mass. Stars with different masses follow distinct evolutionary paths, leading to a variety of stellar remnants. A low-mass star like our Sun will gently shed its outer layers into space. This process occurs over thousands of years, creating a stunning display of cosmic beauty. This creates a beautiful expanding cloud of gas and dust called a planetary nebula. These nebulae can be observed in various shapes and colors, each unique in its own way. At the center of the planetary nebula, the core of the star remains. This core is incredibly dense and hot, a remnant of the star's former glory. This dense, hot remnant is called a white dwarf. White dwarfs are the final evolutionary state of stars like our Sun. White dwarfs are incredibly dense. Despite being roughly the size of Earth, they contain a mass comparable to the Sun, making them one of the densest forms of matter in the universe. They are about the size of Earth but contain a mass comparable to the Sun. This means a single teaspoon of white dwarf material would weigh tons on Earth. Over billions of years, white dwarfs slowly cool and fade away. As they lose their heat, they become less luminous and eventually turn into cold, dark remnants. They eventually become black dwarfs, which are cold and invisible remnants. These black dwarfs are theoretical, as the universe is not old enough for any to have formed yet. High-mass stars, on the other hand, have a much more violent end. Their massive cores collapse under gravity, leading to a spectacular explosion known as a supernova. They explode as supernovae, leaving behind exotic remnants like neutron stars or black holes. These remnants are among the most extreme objects in the universe, with properties that challenge our understanding of physics. Section 6, Supernovae, the spectacular deaths of massive stars. When a massive star runs out of fuel, its core collapses under its own gravity. This collapse triggers a runaway nuclear reaction, resulting in a massive explosion called a supernova. Supernovae are among the most energetic events in the universe. They can outshine entire galaxies for a brief period. During a supernova, the star ejects its outer layers into space at incredible speeds. These ejected materials contain heavy elements that were forged in the star's core. These elements are essential for forming planets and even life itself. Supernovae are not only destructive events, but also creative forces. They enrich the interstellar medium with heavy elements and trigger the formation of new stars. Section 7. Cosmic Alchemy, the creation of elements. Stars are the alchemists of the cosmos. They are responsible for creating the elements that make up everything around us, from the carbon in our bodies to the oxygen we breathe. The process of nuclear fusion in stars combines lighter elements into heavier ones. During the main sequence, stars primarily fuse hydrogen into helium. As they age and their cores become hotter, they can fuse helium into carbon, oxygen, and even heavier elements. The most massive stars can create elements as heavy as iron through nuclear fusion. The elements heavier than iron are created during supernova explosions. These cataclysmic events provide the extreme temperatures and pressures needed for their formation. Section 8. Exoplanets and the search for life beyond Earth. In recent decades, astronomers have discovered thousands of planets orbiting other stars. These exoplanets come in a wide variety of sizes, compositions, and orbits. Some are gas giants larger than Jupiter, while others are rocky worlds like Earth. The discovery of exoplanets has revolutionized our understanding of planetary systems. It has also fueled the search for life beyond Earth. Scientists are now developing telescopes and techniques to study the atmospheres of exoplanets for signs of life. The search for exoplanets is an ongoing endeavor, and each new discovery brings us closer to answering the fundamental question: are we alone in the universe? Section 9. Our place in the cosmos. Stars have captivated humanity since the dawn of time. From the earliest civilizations, humans have looked up at the night sky in awe and wonder, pondering the mysteries of the universe. These celestial bodies have inspired myths, guided explorers, and sparked scientific inquiry. They have served as navigational guides, timekeepers, and sources of wonder. Ancient sailors relied on the stars to traverse vast oceans, while farmers used them to mark the changing seasons. The stars have been a constant presence, a celestial map that has guided humanity through the ages. Understanding the life cycle of stars allows us to grasp our place in the grand scheme of the cosmos. From their fiery births in nebulae to their explosive deaths as supernovae, stars undergo a fascinating journey. This cycle of birth, life, and death is a reminder of the dynamic and ever-changing nature of the universe. We now know that we are made of star stuff. The very elements that constitute our bodies, carbon, oxygen, nitrogen, were forged in the hearts of ancient stars. When these stars exploded, they scattered these elements across the cosmos, eventually coalescing to form new stars, planets, and even life itself. The elements that make up our bodies and our planet were forged in the hearts of stars that lived and died long ago. This cosmic connection binds us to the universe in a profound way, reminding us that we are part of something much larger than ourselves. The study of stars is a journey of self-discovery, revealing our intimate connection to the universe. Astronomers, with their telescopes and instruments, peer into the depths of space, uncovering the secrets of these distant suns. Each discovery brings us closer to understanding our origins and our place in the cosmos. As we continue to explore the universe, we are sure to make even more astounding discoveries about stars and their role in the cosmic symphony. With each new mission, each new telescope, we push the boundaries of our knowledge, revealing the intricate dance of celestial bodies that has been unfolding for billions of years. The quest to unravel the mysteries of the stars is a testament to the enduring human spirit of curiosity and exploration. It is a journey that transcends generations, cultures, and borders, uniting us in our shared quest to understand the universe and our place within it.